Hey everyone, so far we've multiplied and divided rational expressions. We've added and subtracted rational expressions, and today we're going to solve. So the good thing about both of those is, one, we were practicing our factoring. Two, in the adding and subtracting, we were practicing common denominator, because that's going to come into play again. All right, so here we go. What we need to do is we're going to look at a problem, an equation just like this. So when solving rational equations, we need to watch out for extraneous solutions. What that means is that in the denominator, there are things that we can't have happen, okay? One of those things we've talked about in the past is 0 cannot be in the denominator, right? We cannot divide by 0. So we actually have to find what's called domain restrictions before we even start solving. Because as we solve, if one of our solutions comes out to one of those extraneous solutions, we know that we have to cross it off because it can't be there to begin with, okay? So the first thing we're gonna do is practice some of those domain restrictions. Now, when we do this on paper, usually you also state your domain restriction. But maybe on big ideas, if we're using that program for your practice, they might not ask you to type in the domain restriction, but the truth is it's incorporated because you wouldn't have it as a solution since it's a domain restriction. So step one, find those domain restrictions. The way to do that is to set your denominators equal to 0. So if you have multiple denominators, you have multiple domain restrictions depending on what's in that denominator. So right here, we're just going to practice domain restrictions, not solving yet. X plus 5. So we take our denominator and we set it not equal to 0 because it can't be 0, and then we solve. So for A here, our only domain restriction is that X cannot be 5, no matter what, because we can't divide by 0. Here I have two situations. So I'm going to do the first one, which is X plus 8 cannot equal 0. So X cannot equal negative 8. We also have a second domain we have to keep in mind. So we have this 2x squared plus 15x minus 8 cannot equal 0. Well, how do we do this? This is factoring. So we're going to have to keep this in mind. I'm going to factor a little bit so we get back in the habit. So let's see. A times C, which is negative 16. What two numbers multiply to give you negative 16, but add to give you 15? That would be 16 and negative 1. I'm going to do my box. So that A term at 2x squared is up here. Negative 8, that C term is down there. And then we get this negative 1x and 16x. All right, what's in common here is an x. X times what is 2x squared? That's 2x. X times what is negative 1? That's negative 1. 2x times what is 16? That would be 8. And let's make sure 8 and negative 1 is negative 8, so we're good. So we have two values here. We have this x plus 8, and we have this 2x minus 1 cannot equal 0. Okay, now I want you to realize that the x plus 8 we've already dealt with, so we know that x cannot be negative 8. So the only thing we have to consider now is this 2x minus 1. Set that not equal to 0 and solve. So 2x cannot equal positive 1, so x cannot equal 1/2. So we have two domain restrictions for B. All right, now that's just domain restrictions. That's not solving yet. So when solving, these are the steps I want you to come back to make sure you're doing this every time. First, you're going to factor everything. We've been doing that for a couple days now, right? After we factor everything, we're going to find our domain restrictions, just like we did up here, okay? Then what we're going to do is clear fractions by multiplying everything by factors in the denominators. In other words, common denominators, okay? Then what we're going to do is simplify and solve our results, okay? Once we get our results, meaning x equals certain numbers, we have to compare it to the domain restriction just in case. Because if it was one of those domain restriction values, it can't be part of our solutions, okay? So this is an example here. Now, I might do this step just a little bit differently, but I'm just going to say common denominator and go from there, okay? So if we have this problem right here, the first thing we're going to do is factor. And if I see for each of these parts, the only thing to factor is this denominator right here. We can take out an x, the greatest common factor. So right there. Now I notice that my next step is my domain restrictions. So first of all, I have this x plus 3. I'm going to set it not equal to 0 and solve. And then I also have this x, and x can't be 0. So I have two domain restrictions here. Now I don't have to worry about this because I've already considered each part over here. Now I need to look at my common denominator. Okay, my common denominator is x times x plus 3. See, this one's missing an x, this one's missing an x plus 3, and this one has them both. So I don't have to worry about that. Okay, this is a fancy way of trying to do our common denominators, but the truth is, 2, we're going to multiply by x because it's missing an x, right? Whenever we do the bottom, we do the top. The second, we're going to multiply by x plus 3. And the third, we don't have to because now it looks like all of our common denominators. The great thing about common denominators is once we find them, we don't have to look at them anymore. We can look at the numerator. So we have 2 times x, 2x, 3 times x plus 3, there we go, equals 10. And now, hey guys, this is stuff we've done for a very long time, right? We're going to distribute, combine like terms, and start solving. And we get x is 1/5. We compare it back with our domain restrictions. This is good. 1/5 is not part of our restrictions. So our answer is x equals 1/5. Let's try that out now. Okay, step 1, factor. Everything looks good here. 2, domain restrictions. Well, I can't make 3 not equal to 0, but I can make x not equal to 0. I don't have to solve anymore, so that's our only restriction. Now, what I want to show you though, when our next step is common denominator, 6 is 2 times 3. Okay, so really what we're missing here is we're missing a 2, right? And whatever we do to one, we do the other. And we're missing an x. Okay, so that first one, you know what? I'm going to spread this out a little bit more. Let me rewrite this. 2 over 3 minus 1 over x equals 5 over 6. Let me get a new color. Okay, so again, I'm missing here. If I want to make this a 6, I have to multiply it by 2, and I'm missing an x. Whatever I do in the bottom, I do in the top. Okay, so 6x is going to be our common denominator. So in this fraction right here, what are we missing? We're missing a 6. In this fraction right here, we're missing a x. You guys see we have all common denominators now? Now that we have common denominators, we can ignore them. We can look at just the numerators. So 2 times 2x is 4x minus 1 times 6 is 6. And 5 times x is 5x, and we can solve. Okay, I'm going to subtract 4x from both sides. I get negative 6 equals x. Compare my answer to our domain restriction. These are not the same, so the good thing is this would be my answer. Now you can always plug back in to check. All right, let's see how complicated we can get. Remember, step 1 was to factor. So I'm going to draw a line so I can have some space. So if I look, my first expression here is factored. I'm going to leave myself some space. 1 over x minus 2 cannot be factored. We're good. Equals x over. Now, if you look at this denominator, though, this can be factored. These are the difference of squares. Remember, difference of squares, we can just take the square root of each term, and one is going to be addition, and one's going to be subtraction. All right. Remember, even though it's very tempting to go into solving right away, we need to do those domain restrictions. So I'm going to do it over here. So do you guys see? I just have to check x plus 2 and x minus 2. Plus 2 cannot equal 0. So x cannot equal negative 2. And I also have to do x minus 2 cannot equal 0. So x cannot equal 2. So these are what our values cannot equal at the very end. All right, let's do our common denominator. If we see this is our common denominator, this has both the factors. So what are we missing here? We're missing an x minus 2. Now remember, these are groups together. Okay. What is this one? This one's missing an x plus 2. Whenever we do the bottom, we do to the top. Okay, now do we look like we have common denominators? Yep, we can move on. We can ignore the denominator. Look at the numerator. Right here we have 3 times x minus 2 plus 1 times x plus 2 equals, and we didn't have to multiply anything there, so we have an x. Now we're going to solve like we have for a very long time. We're going to distribute and combine like terms. So we get 3x minus 6 plus x plus 2 equals x. Let's combine like terms on this side. I've got 4x minus 4 equals x. Okay, move x's to one side. I get negative 4 equals negative 3x. And divide. So I get 4/3 equals x. Now let's compare it. Is that any of my domain restrictions? No, it's not. So my answer is 4/3. All right, let's do 2 more examples just in case. And then I do have an honors topic in this lesson. All right, remember, first step is factoring. So if I look at the first one here, I do not need to factor. The second one here, I do not need to factor. But what I want to show you in the third one, if you look, 1 is a whole number. And we're looking at fractions really. So what's 1 as a whole number? Well, it's 1 over 1. So if we think of common denominators here, well, let's not doing, what did I just do? I tried to do a step ahead. Stop right there. What was step 2? Domain restrictions. 1 cannot be 0, so I don't have to worry about that. But I do have to worry about x minus 1 cannot equal 0, and x plus 2 cannot equal 0. So if I solve, x cannot equal 1, and x cannot equal negative 2. Ooh, almost went too fast. All right. if I look at all of these denominators, I see that we have an x minus 1, but over here we have an x minus 2, which means I'm missing an x plus 2 over here, not minus 2. Whatever I do in the bottom, I do in the top. Okay, that looks good. Now I don't have to worry about 1, right? Because 1 is just anything multiplied by 1 gets itself, right? So I don't have to multiply this by 1. All right, let's make this look like this. All right, so it's missing an x minus 1. Whatever I do in the bottom, I must do to the top. Remember, they're grouped together because of that subtraction, or that addition. Now I also have to make this one look like it. So if I see, don't just add on an x minus 1. Remember, it's grouped together. So I have to add on an x minus 1 and an x plus 2. Whatever I do in the bottom, I do in the top. Now, does everyone see that now I have a common denominator? I couldn't just say, let me put an x minus. You know, when you have an x minus or an x plus, you have to add on that number with it. It's like that tag along, okay? All right, breathe. Common denominator, right? So we can ignore it. Let's look at the top. Now I'm not going to distribute or do anything like that. I'm just going to rewrite it so we're focusing on that numerator. 2 times x plus 2 plus 2 times x minus 1 equals this x minus 1 times x plus 2. So I want to point this out, guys. This is distribute, but this one you might have to do your box. Unless you know how to FOIL, you can FOIL too. So I'm going to just draw what you would do. X minus 1, x plus 2, and multiply in the box. 1x, 2x, and negative 2. Okay? All right, so let me distribute this into my like terms here. So you get 2x plus 4 plus 2x minus 2 equals x squared. Let's see, 2x and negative x is x, and then minus 2. Okay, again, I just distributed on this side, and I multiplied on this side to get this trinomial. Now, what I'm going to do is move everything to one side. I know we're solving for x, but this worries me. It doesn't really worry me. It just gives me a indication that I'm going to have to factor again, x squared, right? So I'm going to move everything to the left. Let's move everything to the right side because I want a positive x squared. Sorry. All right, let's do this. 2x plus 2x is 4x. 4 minus 2 is plus 2. Now I'm going to move everything over. So I'm going to have 0 on my left side. X squared stays. Now I'm going to subtract 4x from both sides. So if I subtract 4x from here, I get negative 3x. And then if I subtract 2 from both sides, I get negative 4. All right, now what? Well, now I can factor. So you got to keep going. This is a lot of steps, but look, we're in secondary 3, right? We got to do a lot of steps here. All right, so 0 equals. Now you guys can factor, and we factored earlier by doing our box and everything. So I'm going to factor quickly so we can keep going. So this would be coming up to x minus 4 times x plus 1. All right, now how do we solve this? What we do is we set each piece equal to 0, right? Because anything times 0 is 0. So each of these pieces can equal 0. And I solve. X equals 4 and x equals negative 1. Last step, compare with domain restrictions. Are either of these numbers a restriction? No, they're not. So this is our answer. Even though it's a lot of work, you are still doing it correctly. Take your time. Okay, let's do another example, and then you guys can go on and do some practice. All right, let's factor. So 5x, x plus 1 cannot be factored anymore. Do not cross those out. You can't cross those out because of this addition. Equals, well, 4 as a fraction is 4 over 1 minus 5 over x plus 1. Excuse me. All right, that can be factored, so we're good. Step 2, I'm not going to forget this, domain restriction. So let's look at the denominator. The only thing we have to worry about is this x plus 1 cannot equal 0. So x cannot equal -1. Common denominator. Now, remember how I said, when you look at this, guys, and you say to yourself, hey, I'm missing an x plus. You can't just add that in. It's a group. This is a group. So what are we missing? Well, right here, we're missing an x plus 1. Okay, I have to put that together as a group. And whenever I do the bottom, I do the top. Before I make the next step, do I have a common denominator? Yes. If some of you are thinking, but there's a 1 there. Well, anything times 1 is itself, so it's okay. So now, focus on the numerator. 5x equals 4 times x plus 1 minus 5. Remember, I'm just writing it down. I'm not trying to do too much math too early. I'm going to distribute. I get 5x equals 4x plus 4 minus 5. Combine like terms. 5x equals 4x minus 1. Bring the x's to one side. I don't have to worry about factoring because I don't have that x squared. So remember, if you have that x squared, it's an indication you're going to factor again. Subtract 4x to both sides. I get x equals -1. Last step, domain restrictions. Double check what just happened. Our solution came out to our domain restriction, which means it can't be. So after all that solving, I say it can't be that. Now, in this case, we don't have another solution. Where up here we had 2 solutions, right? So if we don't have any solutions, what do we put? No solution. All right, if you are in secondary 3 right now, you may go on and practice, but if you were in honors, I have one more part for you. All right, honors, here we go. We're gonna do inverses again. If you remember, inverses was changing or switching x and y and then solving for that y again. So we're gonna do it with just inverse operations, okay? Or rational equations. We didn't do it before. So remember that f of x is represented as y. So really we think of this as y equals 2 over x plus 3. Next step, we're switching our x and y. So we get x equals 2 over y plus 3. Okay, we are going to solve for y in this case because we need to get that inverse. What do we like? I don't know about you, but I don't like that fraction. So the first thing I'm going to do is multiply that y plus 3 to the other side. We good? Okay. Now, next. This is where most kids are like, I don't know what to do. What's the only thing we could do in this case? The only thing we can do is distribute that x out. So I get xy plus 3x equals 2. Now remember, our next step is to get y by itself. So I'm going to take the things without y and put them on the other side. How I do that, of course, in this case, for positive 3x, is I'm going to subtract 3x from both sides. Got to do that inverse operation. Now how do I get y by itself? I have to divide by x. Or, yeah, divide by x. And I am done. Now, do not cross those x's out. I know they're so tempting to cross out, right? Just leave it at this. But of course, we've learned from inverses that we can't just leave it as y because we didn't have y, right? Inverse representation is f to the negative 1 of x. And then we have our 2 minus 3x over x. This example here is more of a basic example. It could get more complicated. If you see a problem that gets more complicated, ask me, okay? Because there comes a point where we need to do a little bit more right here. But I'm going to stick with the less complicated one for now. All right, enjoy your practice.